So we constructed a graph of this function. Turns out there's something about the graph I didn't tell you. We're going to have to look at that in a minute. So the graph doesn't really look exactly like what I've drawn, but most of the features are there. And I wasn't lying to you. I didn't want to confuse the issue. But there's a question about how the graph approaches negative infinity here and how it approaches infinity there. So I'm going to tell you a little bit about that at the moment. Let's just go through the reasoning. It's very similar to what we did previously. Zeros occur when x is 1 or 6 because those numbers plugged into the numerator give you 0. You could write that as an equation. X plus 1 times x minus 6 equals 0 and solve it. But it's pretty obvious what the zeros are in this case. Sometimes you got to write out the equation. And it's also undefined when x is 2 because that gives you 0 in the denominator, and that's not defined. Then we ask what's the y-intercept. It's a matter of plug x equals 0 because y-intercept occurs on the y-axis, which is where x equals 0. So just evaluate r of 0 is this, and that's 3, and that's an easy calculation. So it's generally pretty easy to get these three things. So we would have a point here, and a vertical axis. Then we got to do a little more reasoning. What happens if you go way to the left? What happens if you go way to the right? Well, way to the left, you got big negative numbers for x, except for large negative x. Well, all three of these numbers here would be large negative numbers. Now, if you multiply two negative numbers in the numerator, and divide by a negative number, it's going to give you a negative. If x is really large, then x plus 1, x minus 6, and x minus 2 are all pretty close to x. And if you have something that's close to x times something close to x divided by something close to x, well, x times x divided by x is just x. So you just get x. So for large negative number, it turns out that r of x is actually pretty close to just x. I'm going to comment more on that in a minute. But the point is that it's going to be, if x is a large negative number, you're going to get a large negative number, r of x. If it's a large positive number, I write, r of x, all three of these would be positive. So you'd have a positive times a positive divided by a positive, which is positive. And, this positive divided by this positive is large, but this one is, so you get a large result. Then we indicate, okay, we've got a big negative, and then we've got a big positive. As we go to the left, as we go to the right, this is end behavior. I think that's the way your book talks about it. And we can do this reasoning. If x is big, then all three of these are big. Multiply big times a big, and then divide by big. You kind of end up with a big. There's a little more detail about that. But so we get the end behavior. As x approaches 2 from below, the denominator x minus 2 becomes tiny. You're going to have a tiny number into whatever you've got up here. Well, if x is close to 2, what you've got up here is close to, I said 8. And 2 plus 1 times 2 minus 6 isn't 8, it's 12. So it doesn't really matter. Number is, but I might as well calculate it correctly. Okay. If x is close to, whether it's coming from the negative side or the positive side, what's coming here or here, your numerator is this, that's going to be close to 2 plus 1 times 2 minus 6, 3 times negative 3, which is negative 12. So we have that negative 8 before that. In that case, then, your r of x is going to be pretty close to negative 12 in the numerator. In the denominator, it gets tinier and tinier. And also, the denominator is negative because if x is less than negative 2, on this side of negative 2, x x minus 2 is going to be negative. So you have negative 12 over a tiny negative number. You're going to get a big result because any tiny number goes into 12 a bunch of times. You're going to get a positive because you have a negative over negative. As x approaches 2 from above, r of x is going to again approach negative 12 over that tiny number, but the tiny number is going to be positive, and that's going to approach them negative infinity. So we see that. Okay, we have a big positive here. We go through the 0 here, and as we approach 2 from the right, our value becomes a large negative number. Over here, we come from big negative, go through this point and this point, and then we approach x equals 2 as a large positive number. Okay, now the one thing that isn't right about this is that this graph is not quite right. And I'm going to explain this separately. I'm going to make the statement and then we'll see it. As x approaches infinity, x plus 1 times x minus 6 over x minus 2 sort of approaches x times x over x, which is x, because if x is big enough, that plus 1, that minus 6, that minus 2 don't make a lot of difference. So in a sense, we would expect maybe this thing approaches the line y equals x. Now, question is this line an asymptote? Should the thing come down like this through here and then kind of curve away toward this asymptote here? And from here, come up through here, then come up, and then approach this asymptote here? Well, it does something very similar to that, except y equals x is quite the right asymptote. So we want to look again at r of x equals x plus 1, x minus 6, x minus 2. Everything we did is right, sort of, except that at the far left and far right, it is quite correct. Okay. If we expand this, r of x is x squared minus 5x minus 6 over x minus 2. Now we can do a long division. I assume that you've done long division of polynomials. I've done earlier in this course. We'll go through the process real quickly. And if you don't understand it, want to look at the video I did for the support course. I'll be glad to send you a link of the item of the map. So, okay. Next. Well, let's do long division, kind of like what you learned in fourth grade. Okay. This is your divisor. This is what you're dividing into. And this is the quotient. Multiply x by x minus 2. You get x squared minus 2x. Now what we want is we want whatever we get here multiplied by this to give us this. Okay, so that's what it means to divide. So this times this has to equal this. So far, we've got x here. Then we've got this much of our x squared minus 5x minus 6. Well, what have we got left? Well, we subtract what we have here. So I'm going to kind of write a little negative sign and a positive sign. Show that what we do is, well, we subtract this, we're really doing x squared minus x and minus 5x plus 2x. That's negative 3x. Then minus 6. Okay, then what do we need? Well, if we have negative 3 here, then negative 3 times x will be a negative 3x. And plus 6 there. So now we'll have, in addition to the x squared minus 2x, we'll have a negative 3x minus 6. And what's that going to leave us? Well, if we subtract the negative 3x minus 6, get this, give us 12. That's our remainder. So then we write plus 12 over x minus 2. Because when we multiply 12 over x minus 2 by x minus 2, we get 12. That gives us 12. That ends the process. Okay. The long division. The long division shows that R of x equals x minus 3 plus 12 over x minus 2. Now, for small x, well, I don't want to say for small x. I'm not going to mention that now. So we're going to leave it off. Okay. For large x, the 12 over x minus 2 is small. So R of x is close to x minus 3. So now when we draw a graph, we have our minus 1 here. We have our 6 here. We have our asymptote x equals 2 here. You know it's down this way, you know it's up this way. But doesn't like a polynomial, it doesn't act like a polynomial as it approaches, and it doesn't just keep getting steeper. It doesn't keep getting steeper on this side. We approach the graph of y equals x minus 3. And we do have the intersection 3 here. So here's negative 3. And here's positive 3. Y equals x minus 3. Is an asymptote. We call it a slant asymptote. The graph will start negative, but it has to start along this asymptote. So it might look something like this. And it has to go through this point, start off close to this asymptote, so it's probably going to do something like this. Close to this asymptote, come down here, and then approaching negative infinity along here. Now your text and your open math, we'll explain that again, but hopefully you've understood. Not for that, but it's going to be easier to understand if you see it in your book. I do recommend that you take a look at that and maybe you can try a couple of problems before turning your attention for the bigger. That way you won't forget whatever you've seen here.